You know how people say the battery is the heart of an electric car? That's only half true. The real boss is the brain that sits on the top of it. And that brain quietly decides how fast you charge, how hard you can floor it, and how long that pack will survive. Hello everyone, I'm Shayan, an engineer specialized in electric vehicle development. In this video, I want to strip away all the mystery around that brain, the BMS, so that when you hear battery management system, you don't just think smart control box. You actually see what it is doing second by second while you drive. Here is the plan. First, we zoom out and look at the whole job of the BMS in simple language. Then we walk through the main jobs one by one, watching, protecting, estimating, balancing, and talking to the rest of the car. And at the end, I'll give you one sentence that sums up exactly what a good BMS really is. So imagine this. You're in an electric car on a cold morning. Battery is at 20% state of charge. You pull up to a fast charger, hit start, and instead of that big number you saw on the brochure, the car charges slower than you expected. Later on the highway, you push the pedal and the car tells you reduce power. Nothing is broken, that is the BMS doing its job. But to you it feels random, almost like the car is moody. Let us remove that feeling. Once you see the big picture of what the BMS is actually doing, all of those weird moments start to make sense. Before we go into details, here's the big picture in one simple line. The BMS is the part of the car that watches the battery, keeps it safe, decides how much it can give or take, and tells the rest of the car what it is possible right now. That's it. Everything else is just details on top of that sentence. Now let us unpack that. The battery the BMS is watching. Inside the floor of a modern electric car, you don't have one big battery. You have hundreds or even thousands of small cells grouped into modules and packs. And each cell has limits it doesn't like crossing. It doesn't like voltage too high, it doesn't like voltage too low, it hates being too hot, it struggles when it is too cold, it ages faster when pushed too hard for too long. Your job as the car maker is to let the driver do crazy human things, road trips, fast charging, full throttle, but keep every single cell inside its safe box. That is the BMS mission, make the driver feel free while quietly keeping the cells out of danger. Job 1. Watch everything. The first job of the BMS is simple to say but hard to do. It has to watch the state of the pack all the time. So what does it watch? It watches cell voltages, pack current, temperatures in different spots, sometimes pack isolation and other signals. Think of it like a nurse in an intensive care room. Every cell voltage is one more patient on the monitor. If one patient goes too high or too low, the nurse has to see it fast. To do that, the BMS uses voltage sensing circuits connected to groups of cells, current sensors on the main lines of the battery, temperature sensors placed on the modules or close to hotspots. It keeps reading these values many times per second, filtering out noise and spikes, so it can see the real behavior of the pack, not just random glitches. Without this constant watching, you cannot have protection, you cannot have good estimates, you cannot have smart power limits. So job 1, see clearly. Job 2, protect the pack. Now that the BMS can see what is going on, it has to act like a strict but loving bodyguard. The pack has hard safety limits: maximum cell voltage, minimum cell voltage, maximum charge current, maximum discharge current, maximum and minimum temperatures. If any of those limits are crossed, bad things can happen. Plating at high voltage, cell damage at low voltage, thermal runaway at high temperature. These are the things that can happen. So the BMS has a set of rules. If any cell voltage is close to the maximum, stop charging or reduce it hard. If any cell voltage is near the minimum, stop discharging and tell the driver to stop. If the pack current is too high during acceleration, cut the power. And if the pack is too hot during fast charge, slow down the charge. If the pack is too cold, limit power and charging until it warms up. To enforce those rules, the BMS controls high voltage contactors and sends commands to the inverter and charger Those contactors are like big switches that connects or disconnects the pack from the rest of the car. The inverter and charger are the machines that pull power out or push power in. So when you see messages like charging limited, power reduced, battery too hot or battery too cold, that is not the car being dramatic. That is the BMS enforcing the safety rules to protect the pack from damage. Job 3. Estimate the invisible state. Watching and protecting are not enough. The driver also wants to know, how full is my battery pack? How healthy is it? How much power can I get right now? Here's the problem. You cannot just stick a dipstick in a lithium pack. So the BMS has to estimate invisible states. The most important are the state of charge, state of health, available power for charge and discharging. A state of charge is basically how full the battery is, usually shown as percent on your screen. The BMS uses two main tools to estimate it. It counts how much current flows in and out over time. It also checks voltage during rest and compares it to the known curve. Counting current is like having a water meter. You know how full the tank was. You watch how much you add or remove. You adjust the level based on that. But this count drifts over time. Sensors aren't perfect. So the BMS also uses open circuit voltage when the car is resting and the current is near zero. The pack voltage settles. That voltage tells you roughly how full the battery is by matching it to an internal map. The BMS blends these two methods so you get a smooth and honest fuel gauge most of the time. State of health is about how the pack has aged. Two main things change with age. The maximum energy the pack can hold gets smaller. The internal resistance goes up. The BMS uses charge and discharge data, temperature history, and sometimes special tests to track these changes over months and years. From that, it estimates how much energy the pack has compared to when it was new, how its resistance has changed, how much power it can safely give without too much heat or voltage drop. This is why your range slowly shrinks over years and why the car might limit fast charging or peak power as the pack gets older. The BMS is updating its model of the pack, then using that model to keep you within safe and tested limits. At every moment, the BMS decides maximum discharge power you can use, maximum charging power you can accept. These depend on state of charge, state of health, temperature, safety limits. For example, low state of charge plus high power demand would push cell voltage too low, so BMS cuts peak power. High state of charge plus fast charging would push cells too close to maximum voltage, so BMS tapers charging. Very cold battery pack would suffer damage if charged too fast, so BMS cuts charge current until it warms up. Has a strong or weak acceleration. Fast or slow charging. Regenerative, that is something strong and sometimes limited. All of that is real-time power decisions by the BMS. Job 4. Keep cells in line. Even in a brand new pack, cells are not perfectly identical. Over time, some cells drift slightly ahead or behind in voltage and capacity. If you never corrected this, one cell could hit the limits earlier than the rest. That one cell might reach max voltage while others are still safe. That one cell might hit minimum voltage while others still have charge. Once that happens, you're forced to cut charging or discharging early, just to protect that weakest cell, so you lose usable capacity. To avoid this, the BMS uses balancing. Most systems use passive balancing. That means for cells that are a bit higher, the BMS bleeds a tiny current through resistor when it is safe to do so, usually at the top of charge. This trims high cells down, letting lower cells catch up. Some designs use active balancing, where energy from higher cells is moved to lower ones, more complex and more expensive. The point is simple. Balancing keeps cell voltages close together, so the whole pack ages more evenly and you can use as much as it is possible without stressing the weakest link. Job 5. Talk to everyone else. The BMS is not alone. It is the one brain in a network of brains in the car. It has to talk to the main vehicle controller, the motor inverter, onboard charger, DC fast charge interface, thermal management system, sometimes telematics or cloud services. Through this communication, it tells others current state of charge, state of health, maximum charge and discharging power, warnings and faults, temperatures and other status. When you plug into a DC fast charger, your car and the charger have a conversation. The BMS is involved in that. It tells the charger the maximum voltage it can accept. It tells how much current or power is safe at this moment. It updates those limits as the pack warms up or gets full. This is why the same charger can give different power. Different cars, different packs, different moments. The BMS is in the loop, deciding what is safe and what is not. The BMS also stores logs and fault data, so service technicians can see what happened during the issue. That history can be used to improve future software and calibration as well. Here is the real challenge with BMS design. The driver wants the car to feel simple and predictable. Press pedal and it goes. Plug in and it charges fast. The battery wants the exact opposite. It wants gentle use, narrow temperature, calm charging, no drama. The BMS sits in the middle of this argument all day. If it is too strict, the car feels slow and charging feels weak. If it is too loose, the pack gets damaged and safety is at risk. On top of that, the BMS has to make decisions with noisy data, changing temperatures, incomplete knowledge about aging, and it has to do this for years in many climates. So a good BMS is not just a set of hard limits, it is a set of smart strategies that adapt over time. Protect the battery, but still give the driver a car that feels fun and useful. If you only remember one thing from this video, make it this. A BMS is not just a battery protector. A good BMS is a real-time decision maker that turns a raw pack of cells into something that feels like a smart energy system. It watches, protects, estimates, balances, and communicates, so that you can stomp on the pedal and plug into a charger without thinking about chemistry at all. Every time you see your charge number, your charge curve, your power limit, that is not magic. That is BMS logic running in the background. Now, when someone says the BMS is the brain of the EV, you know what that actually means. It is the part that sees what the pack is doing, keeps it within safe limits, estimates invisible states like fullness and health. It keeps cells in line and tells the rest of the car what is possible, right? If you want to go deeper into how BMS estimates state of charge and health, you can click on the course link in the description. Thank you.